Okay, so hi everyone. Today we're going to solve this problem, that is 2477 minimum fuel cost to report to the capital. And this problem is a LeetCode problem from the weekly contest 320, and it's the third problem of the contest. So yeah, so it's the third problem, and let's see what this problem is about. So there is a tree that is a connected undirected graph with no cycles, which means that it's the graph, the edges in the tree are bidirectional, and because it's a graph, it is basically an n-ary tree, not a binary ternary, simply an n-ary tree. And that tree resembles a structure that is a country network consisting of n cities numbered from 0 to n minus 1 and exactly n minus 1 roads. Okay, so the countries are, let's say, 0th country, then first country, then second, then third, and fourth. And there will be total, if I say that there are 5 countries, then the number of countries will be 0, 1, 2, 3, 4, and the edges will be 1, 2, 3, 4, 4 edges. And roads are basically edges. The capital city is city 0. Okay, you are given 2D integer array roads where roads I is equal to AI and BI, and because it's a bidirectional edge, so AI is connected to BI and BI is also connected to AI, denotes that exists a bidirectional road connecting cities AI and BI. Now, another point is there is a meeting for the representatives of each city. So, for example, at each city there is a representative, and they want to meet at, because it's a capital city. They want to meet. They want to conduct a meeting at the in the capital city, which means that basically all representatives are traveling towards the capital city. Now, there is a car in each city. You are given an integer seats that indicates the number of seats in each car. So you are there is car in each city. Now you are given an integer that is seats, right? So we can also term this as every representative in of a city has its own car. Now there are seats in a car, right? And every car, every representative have the same type of car, and they have same number of seats, and that variable is given to you. A representative can use the car in their city to travel or change the car and ride with another representative. So for example, you are at cities, let's say X, and there is a representative coming from city Y. Now you are at X, and the representative coming from Y, you will meet that representative in your own city. Now you have two options. Either you can ride along that representative. You will say that, can I pool drive with you, and we both can go to the city, the meeting capital, that is the capital city, that is the meeting point. Or if there is no car that has some vacant space for that representative, then that representative will get its own car with itself, right? Now you need to tell me, now you need to tell, uh, so a representative can use their car, the same thing that I have told you. The cost of traveling between the two cities is 1 liter of fuel, which means that every edge has a value equal to 1. Now return the minimum number of liters of fuel to reach the capital city. Okay. So let's understand this first. Let's understand this by an example. So let's say this is a 0th capital city, and let's say you have this 4, 5. You have these cities 4 and 5. Now 4. Now let's say the seat value is equal to 2, which means that there is a car and there are only 2 seats. So for example, the fourth representative, the fourth city's representative will start its journey, and he will say, or she will say that, let's move to the capital city, and he will take his own car. Now the car has only one seat occupied because of that representative. Now they will reach at first city. Now this city has its own representative, and he will see that the representative coming from fourth city has a vacant seat in his car, so he will travel along with that person. And one fuel is taken for this path, one fuel is taken for this path, so total number of fuel from 14, 1 and 0 will be 2. Now similarly, if there is 5, right? Now if there is 5, this algorithm could be a problem, And in order to deal with that, what we will do is we will not be very fast with our judgment. We will simply say that let's see how many number of people will accumulate to city 1, right? So I will say this will be one person, one representative, this will be one other representative, and total number of incoming people at 2 will be, at first city will be 2 from this side and this side, plus the very own representative of this city, and that will be 1. So there will be total 3 representatives, and for these 3 representatives, if we have a car with 2 seats, then how many cars do we need at 3, which we need to send further on? So it will be out of these 3, maximum will be seated into the cars, and that formula will be number of representatives, or total representatives, divided by number of seats, right? Plus, so this will be the number of people that will fill all the cars and will fill all the seats in, let's say, X cars, right? And then we have remaining. Now we need to count the remaining representatives, and that can be counted by total representatives modulus seats is not equal to 0 or greater than 0, and these are the remaining representatives. So the sum of both these two, x plus remaining, will be equal to the cars that we need, number of cars that we will send further on. And by further on I mean the outgoing edge, and outgoing edge will be will contain 1 unit of 1 kilometer of distance, and for that 1 kilometer of distance we will say cars. If there are, let's say if there are z cars and they are going to travel the 1 kilometer distance, then z will be the total liters of fuel that is used, right? This is a very simple observation which we have observed, and from this observation we can make an algorithm and calculate our answer. So I will say that from city 4 it will be 1 person, from 5 it will be 1 person, and at from city 1, how many people I'll be sending to city 0? It will be 3, right? And the fuel I am calculating on the way, and the fuel that I have calculated from this part is 1, this part is 1, and at this part it will be 3. So it will be 1 plus 1, right? This fuel, and we need to send 3 cars, not 3 cars actually, the number of cars will be different. It will be 3 by 2 plus 3 modulus 2 greater than or not equal to 0, it's the same thing, and that will be 1 plus this will be 1, and it will be 2. So it will be 1 plus 2, the number of fuel for this path, and similarly we can calculate the fuel for this one, and this one. Now let's see how we can solve this question. So I think algorithm is pretty clear. Now another main thing is node is equal to city. Each node in a graph will be a city, and the number of cities will be from 0 to n minus 1, and roads is equal to edge, which are bidirectional edges. Now let's see how we can solve this problem. So first thing first, we are given an vector, a 2D vector, or edges vectors, right? We need to convert it into a graph data structure. So I will say that unordered map of int, that is a current node, and vector of int, right? And this will be my adjacency list. Now let's construct the adjacency list. So for loop, not I is equal to 0, it's actually vector of int a single road that we have taken from roads vector, a single edge that we have taken from roads edges, and first we will have a source node, and that will be road of 0 index, and then we have destination node that is equal to road of first index. Now adjacency list at source will have an adjacent as destination, adjacent node as destination, and adjacency list, because it's a bidirectional thing or graph or an edge, it will have pushback source. Right now source is connected to destination, and destination is also connected to source. Then we will call DFS function on this graph adjacency list, and the start node will be 0, the previous node will be 0, because we need to take because in n-ary trees that we don't end up in a cycle of node is traveling to destination and then to source and then again to destination and source. To avoid this cycle, we need to keep track of the previous node. And we also have, let's say, int fuel, that is equal to, not int actually, long fuel, that is equal to 0, right? So I will say fuel, and before that I will also give a variable as seats, and then we have fuel, and I think that's it. Yeah, so then I will return my fuel as my answer. And now let's build the function. So it was a DFS function, and this function, as I've told you earlier, we are, for every node we are basically returning the number of people that are incoming to that node, right? So it has to be a int DFS function because it's returning the number of people. And the first thing first, we have an unordered map, int vector, and a reference of adjacency list. And yeah, another thing is int node, the current node that we have and the previous node that we have, and then seats variable, and then int fuel. Now fuel is a reference variable because we will be adding fuel while backtracking, so it needs to be a reference variable. Now, so the first thing will be to initialize the number of people. So people or representative, let's say, that I will find at the current city will be equal to 1. We cannot initialize this variable with 0 because we will have at least one representative at the current city, right? And now we will now we will initiate a BFS. So I will say adjacent node from adjacency list of this node, all the adjacent nodes. Now if the adjacent node is equal to the previous part, then simply continue because we don't want to end up in a cycle. Otherwise, people or representative will be plus equal to the further DFS calls that I will make, and that will be adjacency list as it is. Then we need a node. Okay, so now the current node is going to be adjacent node and the previous node is going to be node, and seats variable as it is and fuel variable as it is. Now after this part, I will say if node is not equal to 0, because 0 at 0, we don't want to send any car from the capital, right? We need to send the car further on if it is not a capital, right? So fuel will be plus equal to, now the formula that I have shown you, total representative divided by seats. So that means representatives divided by seats plus of representatives modulus of seats is greater than 0 or not equal to 0. It's the one and same thing. And we will return the number of representatives, right? So I think this is enough. And yeah, there's one mistake. So it's not int fuel, it's actually long variable. And yeah, I think we're good. Let's check it out if this will work. Yeah, seems good. Let's submit it. Okay, so yeah, so this was it. This is the question, and I think it can be solved by other methods, but so this is the method that directly came into my mind. I have explained you my intuition and the thought process for this question. So yeah, that's it guys. Thank you for watching and have a good day. Bye.